so today is our review. The review is just like the quiz you're going to see tomorrow, okay? So let's figure this out. So first of all, write this solution, this number line, in interval notation. Now remember, if it's a bracket, it's a solid dot. If it's a parentheses, it's an open dot. So number one is as easy as this. We go parentheses, -3, comma, 4, bracket. I have faith you can do this tomorrow.
So if it's infinity, then it goes the other direction.
Yeah, if there's an infinity piece, then you're going to have a parentheses for sure, okay?
If it's going to that way, then it means infinity.
Right, right. Okay, number two, graph this number line. So, first of all, we know that -4, 1, and 4 on it. So if I go, boom, 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 let me put my little dashes in here so I can put in my numbers. Let's go 0, 1, 2, 3, 4, 5, -1, -2, -3, oops, -2, -3, -4, okay? So I'm going to do my number line, put the dashes in there for each spot. So when I take a look at what's going on in here, the first thing, I'm going to definitely have some dots at -4, 1, and 4. Okay, so on my number line, I'm going to go ahead and put a dot at -4, but I'm going to put an open dot at -4 because there is no equal sign. So I'll go to -4, and I'll put an open circle right there. So I'll go ahead and put my open dot at -4, okay? At 1, it does equal 1, so I'm going to put a closed circle because -1 is part of the answer. And I'll go to 4, and I'll put a closed dot at 4 because there is a little equal sign. So it includes 4, okay? Now, where do we shade? Well, let's read things. Okay, now first of all, if I read the whole thing, and everybody watching? Let's read x first. Read it backwards. X is greater than. Greater than means, greater than -4 means we shade this direction, right? Greater than -4. But we also want to be less than or equal to 1. So our values are in between -4 and 1. So we shade all of that. Okay, so, let's see. So I'd have a open circle, shade, close circle, okay? Now the second part of this thing says it's greater than or equal to 4, so it's bigger than 4. Well, 5, 6, 7, 8, blah, blah, all the way to infinity. So I'm going to go from 4, and I'm going to make my arrow at the very end bigger and darker to show that it goes to infinity. Okay? All right, pretty easy so far. Okay, number 3, list the numbers in order from least to greatest and identify the types of numbers. So, okay, what would be helpful for me is if I knew what some of these were as decimals. So I know pi is 3.14. I know that. The square root of 3, if I use my calculator, and I go the square root of 3, it's about a 1.73, so the square root of 3 is about a 1.73. And 4/5 I know is 0.8. Okay, so if I know those values, then it helps me put things in value from least to greatest. Okay, so the smallest is obviously -4, so I'll go -4, comma, probably my -1.2, right? -1.2, 0, 4/5. Let's see then, probably my square root of 3, square root of 3, 2, and then pi. Okay, there it is, listed from least to greatest. Okay, now what are the names of these? Well, this is an integer, so the -4 is an integer. -1.2. -1.2 is a decimal, but it can be changed to a fraction, so it's rational. Any number that we changed into a fraction is a rational number.
How do you know if it can be turned into a fraction?
Great question. Any decimal that isn't ugly like pi or like a square root number can. Any number, except for these ugly ones. Any number can, okay? So 0. 0 can be a lot of things, but it's most specifically a whole number. I mean, it can be a lot of different things. It could be an integer. It could be a rational number. But it's more specifically a whole number, okay? 4/5 is definitely a rational number because rational numbers are fractions. So this one's definitely a rational number. Square root of 3 is one of those ugly decimal ones. It's irrational, right? If it's an ugly decimal, it goes on forever. It's irrational. Two could be a lot of things, but it's most specifically a natural number. And pi, of course, is that 3.44, blah, blah, blah. It's an irrational number. Okay, how's that? So when you list these, I want its most specific, because 0 could really be a lot of things. Actually, all of these could be real numbers. You could put real number, real number, real number, and you'd be right, but I would mark it wrong because I want the most specific thing it is, because they're all real numbers. Don't put down real numbers for them all because you're not going to get it right. I want the most specific, okay? Okay, square roots. You ready? Number 4. All right, let's see if we can do this. Okay, so 4. And what two multiples am I going to use?
9 and 2.
9 and 2. Square root of 9. Square root of 2. Good job, Megan. And then I'm going to take the square root of 9, right? Square root of 9 is a 3. 4 times 3 is 12. Square roots of 2. There it is. Okay. Number 5. Now the rule is you can't add them if they're different. But maybe we can make them the same. Maybe. So what do you think about 18? We already did that one. 9 and 2, right? We just did it. 9 and 2. But what about 50? What about 50? 25 and 2, right? 25 and 2. 25 and 2. Okay, it's kind of squeezed in there, but I got it. Square root of 9 is 3, right? Square root of 2. Square root of 25 is 5 with another square root of 2, okay? Am I going slowly enough? That's 3 times 3. It's not 6. 3 times 3 is not 6. It's 9. Square root of 2 plus 10 square root of 2. Now we can add them. We've made it so they're both the same root. 9 of these plus 10 of these makes a total of 19 square roots of 2. Okay. How am I doing? Okay? Okay, let's look at number 6. So, they're both square roots, so let's multiply them. Square root of 5 times square root of 10 makes the square root of 50. And lo and behold, we did that. We just did square root of 50, didn't we? So this one's not going to be hard. Yeah, if they're both square roots, I can multiply square roots. So then I'm going to rewrite this as 25 times 2 square root of 25 times the square root of 2. And the square root of 25 is just 5 square roots of 2. What you can't do, Megan, is you can't multiply square roots with non-square roots, like this one. Those you can't multiply, because that's a regular number and that's a square root. But you can multiply square root to square root, okay? Okay, 7. You guys ready for 7? Now, first thing I notice is the 16. So if I rewrote this as the square root of 16 over the square root of 5, right? Then what I see is the square root of 16. I can do something with the square root of 16. Square root of 16 is just plain old 4, right? Alright, now, there's a problem. You can't have a square root in the denominator, right? So we fix the problem with the problem. The problem is the square root of 5, so we multiply by the square root of 5 over the square root of 5, alright? And we'll wind up with 4 square roots of 5. And I'll do every step over the square root of 25, right? 5 times 5. But the square root of 25 is just 5. So I'm going to rewrite this as 4 square roots of 5 over 5. Don't divide the 5s. That is not a 5. That's 2.24 blah blah blah. That is not a 5. That's 2.24 blah blah blah. Don't divide those, okay? Okay, ready to turn the page? Seem pretty easy so far? Okay. All right, on the back side, simplify. All right. Number 8. Probably the easiest way to do this one first is when you have an exponent to an exponent, you multiply. So we're going to multiply exponents here, okay? So I'm going to get an x to the 20th and a z to the negative 12th, okay? I just multiplied exponents, okay? And then with the negative exponent, I'm going to bring the z to the 12th down. Okay, Jamie, when we bring it down, it makes a positive, right? So brought the z to the 12th down, and then the x to the 20 stays up above, okay? Okay, number 9. So I see negative exponents, so let's make a little fraction bar. Okay. I do know that 30 divided by 5 is 6. I can at least do that, right? 30 divided by 5 is 6. And now with the negative exponents, they're in the wrong place. So I move them. So I'm going to take and move x to the negative 5 up, x to the negative 2 down, and I'm going to move my y to the negative 1 up. So if they're negative exponents, they're in the wrong place. So what I have to do is fix it. So I have to move them either up or down. So the x to the 5 comes up to x to the positive 5. So when I move it up, it becomes positive. The x to the negative 2 I move down, we get x to the positive 2. So with negative exponents are in the wrong place, I just move them. And the y to the 1 I move up, okay? Y to the 1. Now I still had the y to the 4th. Okay? Now the y to the 4th is a positive number, right? So leave it where it's at. It's on the top, leave it on the top. So keep the y to the 4th here, okay? Okay, I'm getting close. Now the 6 is fine. Leave the 6 where it's at. 2 of these x's will cancel out 2 of these x's, right? So I'll be left with x to the 3rd. But on top, right? Because 2 would cancel 2 here, there'd be left 3 left over on top. x3. And y to the 1, y to the 4th, combine them, it makes y to the 5th. And there's really nothing on the bottom except for maybe 1. All right, you ready for 10? All right, 10. Let's multiply. So actually, there's 2 ways to do this. Let's do it the easy way, okay? We're going to add exponents, okay? That's the easy way to do it. So I'm going to get 48 x to the 2nd, because I add them. I got 5 and a negative 3, x to the 2, and a y to the negative 7. That's really the easiest way to do this one, okay? Let's fix it. We've got a negative exponent, so let's make a fraction bar. The 48 stays on top. The x to the 2nd stays on top. And the y to the negative 7 comes down as a y to the positive 7. All right, and that is it. Now our homework is just going to help us get ready. It's a little bit of a review.